Hi, this tutorial covers significant digits. So let's start with an example here. So the following data gives the temperature in degrees Fahrenheit of 7 Minnesota lakes on the first day of July. Temperatures were measured to the nearest tenth of a degree. So 62.3, 70.5, etc. So we have 7 total data values. Okay, so let's start by determining the mean lake temperature. Okay, so I'm going to just go ahead and add these up. Okay, so I'm going to add all those up, and then I would like to divide by 7. Okay, so I end up with 67.743. Okay, so I'm going to report that number. Okay, so if I reported it that way, there's going to be a little bit of an issue with the way I reported that. So since the original data was measured to the nearest tenth, okay, all of those values were point something, it is inappropriate to present the mean rounded to the nearest thousandth, like I did here, tenths, hundredths, thousandths. If this is done, the mean measurement gives false precision. Okay, so false precision is the presentation of numerical data in a way that implies better precision or exactness than actually is the case. Um, Another example of this that's pretty commonly used is, let's say you're going to a museum, and there's somebody working at the museum, and you ask them, how old was this fossil? And he would repeat, he'd say back to you, well, it's about 70 million and 6 years old. And you'd say back, 70 million and 6? He's like, well, yeah, the first day I got here, they told me it was 70 million years old, and I've been here for 6 years. Okay, that would be an example of false precision, because clearly that 70 million number is not an exact value, whereas the 6 years isn't a very exact value. So when you're combining two values that were measured to different exactness, it's important that you don't combine that, so you don't get that false precision. All right, so the mean in the lake example should have had the same number of significant digits as our original data set. So what I mean by that is that it should have also been rounded to the nearest tenth. So I should have reported my mean as just 67.7 instead of the extra place values. Okay, so in this case, this number here has what we call 3 significant digits. Okay, so 1, 2, 3. So the digits in a number that contribute meaning to a number's precision. So these 3 numbers were how precise I wanted to measure my temperature to, which was the same as how actually I collected the data. So it's important that when you report your answer with the same number of significant digits as you collected the data. Okay, and then one other thing, if a series of calculations is to be done, rounding to an appropriate number of significant digits should only be done when the final result is presented. So if we think about, if say we wanted to also calculate the standard deviation of this data set, since my standard deviation calculation involves the mean, I would not want to round my mean to 67.7. I would want to actually use as many digits as possible until I finish my standard deviation calculation, and then when I report my standard deviation, then I round. Okay, so when you're dealing with these significant digits issues, make sure you only round once and you round that value right at the end. So that has been the tutorial on significant digits. Thanks for watching.